In this section, we'll take a look at digitizing vector data and some common digitizing errors. First of all, it's important to be aware of the different types of digitizing where you might encounter points and various other objects. So points are used for single features. That's the only time that you will encounter digitizing a point. For example, you know there's a well location or a tree location, and you digitize on screen and place a point within a feature class that's georeferenced. Nodes form the line endpoints. So the difference between a node and a vertex is that a node is the endpoint of a line, whereas a vertex is simply a control point that controls the shapes of lines and polygons, but they're not endpoints. Nodes will sometimes become intersecting endpoints as well, where you have lines intersecting. So when creating points, again, you'll be using heads-up digitizing, either digitizing single point features or using the sketch tool and snapping features to digitize more complex lines, positions of particular points, or polygons. In this case, this is one of the tasks that's done in the lab manual, and you'll be creating a line that represents a bus route and then digitizing bus stops. Points are added as XY event files, and points added using geocoding functions will be dealt with in Chapter 8, the chapter that deals with geocoding. Lines are digitized with starting and ending points, with shape vertex points as needed. So again, nodes form the beginning and end points, and vertex points form the in-between points that give the line its shape. Lines, points, and polygons all have attributes. In the case of lines, the line has a shape. It has a from and to attribute as well. You can then use that to include address information for geocoding or latitude and longitude positions, and then also include other attributes as needed. The length is calculated as well and appears in the attribute table. And the length relates only to that particular line segment. Polygons are formed from 3 or more lines that are joined to form a closed area. And there are 2 different ways that polygons may be formed. They may be single polygons, for example, Lake County, Ohio, or multi-part feature polygons. Polygons with multiple parts, for example, would be the Hawaiian Islands. So you might want to create a map of the United States, and it has one recognized polygon for each state. But what do you do with the case of the Hawaiian Islands, which has multiple islands? Well, they can be associated together, those multiple features, to basically form one feature class recognized polygon form. Polygon attributes will include the shape, the area, the perimeter, and the length of the polygon. Common digitizing errors are the focus of the next slide. There's something that you'll become more aware with as you work with the editing and digitizing tools in ArcGIS. This slide shows some common digitizing errors. On the left are a number of the more common topological errors that typically result from user mistakes while digitizing. Dangles, switchbacks, knots, loops, overshoots, undershoots, and slivers are all common problems when digitizing is not done correctly. Typically what happens is that either there's a mismatch in scale compared to the data, the source data, or the level of detail that's being captured. Sometimes the user is trying to capture less detail than may be needed. They might be better off by operating at a different geographic scale. Maybe they're trying to capture too little detail compared to the types of features. The methods of the digitizer are also very important. A good understanding of the source data and a good understanding of the tools available in ArcGIS will help you avoid most of these errors. For example, in the case of undershoots and overshoots, snapping tools can help avoid that. You'll learn about doing snapping in the tutorial manual. You can avoid problems like loops and knots with more careful use of the digitizing process, and again by possibly using the trace tool or using other features available within the editing process. So you can see that with more experience and better knowledge of your data and better knowledge of ArcGIS functions, you can avoid most of the errors that might happen when digitizing. You'll probably never be able to avoid all the errors, but there are a lot of tools at your disposal that should make digitized data just as high quality as other data that's being captured. That concludes this section. Next, we'll move on in section 3.3 to transforms and spatial adjustments within the digitizing process.